So we want to continue in section 3.8. So we were looking at transformations of functions, and we want to look at what are called piecewise functions. Piecewise functions. But basically what a piecewise function, it's a function, it's kind of like a machine, right? A function is a machine where you have inputs and outputs. But it's broken up into different pieces, you might say. So let me give you an example here. Let's say I got this function, f of x, equal to the following. So we're going to have two pieces to this function. First of all, we're going to have x squared is going to be your output. If your input, x, is greater than or equal to 0. And it's going to be minus x. That's going to be your output, minus x, if x is less than 0. Basically, you have two types of output. So here's the deal, man. Here's the deal. You got f here as your function, right? It's your machine. And over here, you got your inputs, right? Your x's, your inputs. Now you're going to split this in half. So on one hand, we're going to have those numbers, those x's, that were going to be greater than or equal to 0. I'm going to call those the red values. And you have, on the other hand, the blue values, right? Those guys are less than 0. So these are the x values that are less than 0. So if I get an x value that's greater than or equal to 0, I'm going to plug it in the machine, and out the other side, this is going to come out the other side. It's going to give me an x squared. X squared will be the output. So over here we got the output. So I'll make a little set here. If I plug in a greater than or equal to 0 x value, an x value greater than or equal to 0, the outcome is going to be x squared. And what happens if I plug in an x value less than 0, a blue value? If I plug that dude in, it's going to go into the machine. It's going to come out the other side. It's going to come out as negative x. It's going to flip the sign on the input to get the output. Well, that's what a piecewise function is. So you can plug certain things into the function, you'll get out some other type of thing. You can plug something else in, you get something else. It's kind of like a machine that can do multiple things. So maybe I can plug in a piece of metal into the machine and I get a nice manufactured, I don't know, a nice manufactured pen or something. I don't know what's made out of metal. Or maybe I can put in a nice piece of wood in the machine and out the other side comes out a nice shelf or something. So this machine is able to handle multiple types of things. It gives me different types of outputs though. Okay. So let's see, can we actually evaluate this function? Evaluate. Now let's write it down. Evaluate the function. F. I'll just write evaluate. How about evaluate? We'll just write evaluate. So number one, let's say we want to evaluate f at 2. Number two, let's say we want to define f at -4. So on and so forth. Now let me give some more space there. Let's say we wanted to evaluate the function f at 0. And number 4, let's say we wanted to evaluate the function f at -1. Okay, so how do I do this? How do I do this? So I'm first going to say, okay, number 1, f of 2. So number 1, f of 2. So I want to focus on my 2 here. Is my 2 greater than or equal to 0, or is it less than 0? In other words, is 2 a red value, or is it a blue value? 2 is going to be red, right? The input 2 is greater than or equal to 0. That means I'm going to go up with this output here. I'm going to deal with the x squared. So I'm going to plug in, instead of an x, I'm going to put a 2 in place of the x. I use the red rule of assignment there. So I get 2 squared equals 4. So there's my answer. Now next I'm plugging in -4, right? Number 2, I'm plugging in -4 for my input. Now -4, is that greater than or equal to 0? Or is that less than 0? Well, negative 4 is less than 0, right? So it's a blue value. Right, blue values are less than 0 values. So what we're going to do, we're going to plug it into a minus blank, a minus x. So in place of the x, we're going to put the minus 4. So basically what happens here is we get a double negative. Right, a double negative becomes a positive, so you just get, this is equal to 4. All right, so 4 is your answer there. What about 0? 0, so this is number 3. The input 0. The input 0, is that greater than or equal to 0, or is that less than 0? Well, 0 is greater than or equal to 0 because it's equal to 0. So 0 is actually a red value in this case. So we're going to plug that into blank squared. Right, x squared is the outcome there. So in place of the x, we're going to put a 0. So 0 squared is what we're going to do. 0 squared is 0. And finally, f of negative 1. This is number 4, f of negative 1. So the idea is we're plugging in a negative 1. Negative 1 as an input, as an x value. Is that greater than or equal to 0, or is that less than 0? Well, negative 1 is less than 0. So it's a blue value. So I'm going to set up my blue template. I have what? Negative x. So I'm going to have negative blank. And in place of the blank, I'm going to put that minus 1. We're going to get a double negative again, and we're going to have just a 1 for an answer. All right, let me box that properly. Now let's say we actually wanted to graph that piecewise function. Let me just rewrite what the function was so we'll have it. What was the function? It was f of x equals x squared if x is greater than or equal to 0. And it was what? Minus x if x is less than 0. That was the function. So basically we're going to think about this first part here, the red part. I'm going to think of this as, okay, so f of x is the same thing as y. So right now we're thinking about this as y. So we're going to have what? Y equals x squared if x is greater than or equal to 0. So we're going to focus on this red part. All right, so here we go. I'm going to graph this. This is going to be my, what do you call that? Y-axis. It's going to be my x-axis here. It's not quite to scale or anything like that. Oh, let's do that. Make it a little better to scale. Here's my x-axis. Here's my y-axis. So what's y equals x squared look like? Y equals x squared. Well, that is a parabola typically, right? Typically it's a parabola where you have key points, right? You have 0, 0, 1, 1, 2, 4. You have negative 1, 1, negative 2, 4. And normally it does something like this, right? Imagine doing that very lightly with your pencil, extremely lightly with your pencil, because you might have to erase part of this graph. Now, pay attention to where we are supposed to keep this graph. So it says when x is greater than or equal to 0, when x is greater than or equal to 0. If you think about when x is greater than or equal to 0, that is to the right of the y-axis, right? X is greater than or equal to 0 here to the right. Right, you have greater than or equal to 0 here to the right. So that means I'm going to keep my red function to the right of the y-axis. And that means to the left there, I'm going to get rid of that left part of the parabola, that dashed line there to the left. So I'm going to get rid of this here. There we go. Okay, so we're keeping the right, to the right of x is 0, right? To the right of x is 0. So to the right of the y-axis. Now, we got to do the second part of the function, right? We got one piece, we got a second piece. So the next one, we're going to call this, right, f of x f of x is the same thing here as y, right? So that's y equals negative x. So y equals negative x. And that's if x is less than 0. So my question is, what is y equals negative x? Well, you think about it, right? Y equals, I'm going to write negative 1 x plus 0. That's a line, right? Remember when we did lines? Lines, this is a line. It has a y-intercept, a b value, right, of 0. When you're talking about y equals mx plus b, this right here, this 0, this green 0, that's your y-intercept. And it has a slope of, remember y equals mx plus b, it has a slope of m equals negative 1. Right, that's your slope. Now negative 1, you can think about it as a fraction, right? Negative 1, you can write it as negative 1 over 1, or you can write it as 1 over negative 1. Either of those can be useful. So I'm going to graph that very lightly in blue, and we're going to figure out where do we need to keep this blue line. So I'm going to start off with my y-intercept here. My y-intercept of 0, so along the y-axis right here. And we're going to do a slope of 1, negative 1. I'm going to use this version right here of the slope. So I'm going to go up 1, over 1, up 1, over 1, up 1, left 1, right? Up 1, left 1. I'm going to get points. Get me some points. Right, that's the idea. So the top number tells you your rise, the bottom number tells you your run. So we're going up 1 and then left, up 1 and left. And generally speaking, you have a line that does something like this. You connect those points. The question is, where do we actually keep this line? Where do we keep this line? Well, if you read back here, I'm going to circle this in black. You're going to keep this line when x is less than 0. So x is less than 0 over here on this side. Right, x is smaller than 0 when the x values are negative. That's to the left of the y-axis. So we're going to keep this blue line here to the left of the y-axis. So that means we're going to get rid of it to the right of the y-axis. We're going to have something that looks like, oh crap, I lost something, didn't I? It's a stupid thing. Just going to write. Yeah, there it goes. I lost a lot of information. That was a point there, and that was all nice and good. That was a nice, supposed to be a nice, okay, so we're filling in this blue line here. Yeah, we had that filled in. Okay, so that's our graph. I'm going to get rid of these purple stair steps. You don't need those. That's for your slope. I was showing the slope there. Don't erase everything. There, well, I lost a black tick mark there. There we go. There it is. There's your final graph. This is y equals f of x. That's what this is. It's a piecewise function. It has two pieces. It has a blue piece and a red piece.